Fundamentals of Cloud Computing and Security Navigating Our Cloud Migration by Tenerio Phillips. Introduction to Cloud Computing. Cloud computing is a technology paradigm that involves delivering a variety of computing services, including storage, processing power, and applications over the internet. Instead of relying on local servers or personal devices to handle applications, users can access and utilize computing resources as needed from remote and data centers. Types of cloud services and models. Infrastructure as a service at IaaS. IaaS provides you virtualized computer resources over the internet. Users can rent virtual machines, storage, and networking infrastructure on a pay-as-you-go basis. Users have control over the operating systems, applications, and network components. Platform as a service, PaaS. PaaS provides a platform allowing customers to develop, run, and manage applications without dealing with the complexity of building and maintaining the underlying infrastructure. Software as a service, SaaS. SaaS delivers software applications over the internet, eliminating the need for users to install, manage, and maintain the software locally. Examples include email services such as Gmail, customer relationship management CRM tools, Salesforce, and Office productivity suites such as Microsoft 365. Desktop as a service, DaaS. DaaS delivers virtual desktop environments to users over the internet. Instead of running applications and storing data on local devices, users access the virtual desktop hosted in the cloud. Users can also access their desktop environment from various devices, providing flexibility and mobility. Virtualization platforms. Here are some key roles in cloud computing. Efficiently utilizes physical resources by running multiple virtual instances on one server. Isolation ensures applications in one virtual machine do not interfere with others. It also has flexibility and scalability, which enables quick creation, deployment, and scaling of virtual machines. It also has a disaster recovery that simplifies backup and recovery by encapsulating entire virtual machines into files. Some examples of virtualization platforms include VMware and vSphere or slash ESXi. Is widely used suit for server virtualizations and hypervisor. Microsoft Hyper-V is Microsoft's hypervisor for virtualizing Windows environments. You also have KVM, kernel-based virtual machine. It's an open source solution integrated into the Linux kernel. You also have Xen, which is an open source hypervisor supported by x86 and ARM architectures. And you also have, of course, the Oracle VirtualBox, which is free and open source software for creating and managing virtual machines. Service-oriented architectures, or as we like to call it, SOA. SOA structures software as independent modular services. These services, with standardized interfaces, promote interoperability, reusability, and flexibility in software development. SOA and cloud services. Interoperability, or SOA, supports seamless communication and integration between diverse cloud services. Modularity, which is SOA's modular approach, aligns with the scalability and flexibility needs of cloud computing. Flexibility is a loose coupling, and SOA allows for rapid adjustments in the dynamic cloud environment. Service discovery. SOA facilitates the dynamic creation of composite applications by discovering and combining existing services. Benefits of SOA in the cloud. Its agility. SOA enables quick adaptation to changing demands in the cloud. Its cost efficiency. Service reuse reduces development costs in the cloud environment. Interoperability. Standardized interfaces in SOA ease integration of diverse cloud services. Adaptability is SOA's flexibility supports easy adjustment to changes in business requirements or technology. Collaboration. SOA fosters effective collaboration among development teams in the cloud, enhancing service integration. Deployment models. Deployment models overview. Private cloud. Dedicated cloud infrastructure for a single organization. It provides enhanced security and control but requires higher upfront costs. The public cloud. Services offered to the general public by a cloud service provider. It's cost effective, scalable, and managed by the provider. Community cloud, shared cloud infrastructure among organizations with common interests, offers collaborative benefits and shared costs for specific communities. A hybrid cloud. A hybrid cloud is a combination of private and public cloud services. It provides flexibility, allowing data and applications to move between environments. Considerations for deployment model selection. Security and compliance. Evaluate data sensitivity and regulatory requirements. Its cost and scalability. Consider budget constraints and scalability needs. Its performance. Assesses the requirement level of performance for applications. The data control. Determine the extent of control over data and infrastructure. Flexibility. Choose a model aligning with dynamic business needs and growth. Local versus cloud comparison. Local resource requirements relies on local hardware, potentially requiring substantial upfront investment. Control offers a high control over infrastructure and data, but demands local management. The cloud resource requirements: minimal upfront investment, scalable resources on demand. Control shared responsibility with the cloud provider, reducing direct control but outsourcing management. Network local dependent on local network infrastructure, subject to potential limitations. Cloud requires robust internet connectivity with data transmission relying on external networks. Security attacks. Local systems vulnerable to physical breaches. Cloud faces cyber attacks. Mitigations. Local security often relies on physical measures. Cloud providers implement robust cybersecurity measures. Vulnerability. Local vulnerabilities tied to physical assets. Cloud vulnerabilities linked to online threats and shared infrastructure. Security, storage, legal/privacy issues. Security best practices. Cloud. Employ encryption, multi-factor authentication, and regular audits. Local. Implement firewalls, antivirus, and secure access controls. Data storage. The cloud. Utilize scalable, flexible storage, data redundancies for reliability. Local. Dependent on the physical storage capacity, local backups may be required. Legal/privacy considerations. Understand data residency requirements and legal implications. Compliance. Ensure adherence to data protections regulations such as HIPAA or GDPR, which is HIPAA or GDPR. In this presentation, we embarked on a journey through the fundamentals of cloud computing and its crucial intersection with security. We explored the transformative nature of cloud computing, where computing services are delivered over the internet, enabling an on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Diving into the various cloud service models, we encountered infrastructure as a service, platform as a service, software as a service, and desktop as a service. Each model offers unique features and uses cases, influencing resource management and control in different ways. Virtualization platforms, including VMware, Hyper-V, and KMV, were discussed for their pivotal role in optimizing resource utilization, a crucial aspect of cloud cloud computing. Your journey continued into the realm of service-oriented architectures with a design approach of structuring software as a modular service enhances interoperability and flexibility. SOA not only aligns seamlessly with cloud principles, but also brings benefits such as agility, cost efficiency, and adaptability. The discussion extended to deployment models, private cloud, public cloud, community cloud, and hybrid cloud, each with distinct characteristics. The consideration for selecting the appropriate deployment model were highlighted, emphasizing the importance of aligning the choice with organizational needs. With a crucial comparison between local and cloud environments touched upon resource requirements, control, network considerations, and security aspects. Understanding these differences is vital for making informed decisions during cloud migration. Security, storage, and legal/privacy issues were explored in depth, covering best practices, data storage considerations, legal compliance, and the implications of data protection regulations like GDPR and HIPAA. As we conclude, it's imperative to underscore the paramount importance of security in the cloud migration journey. The dynamic landscape of cloud computing offers unparalleled opportunities for efficiency, scalability, and innovation, but these must be coupled with robust security measures to safeguard sensitive data and ensure regulatory compliance. Thank you for accompanying us on this exploration of the fundamentals of cloud computing and security. Your understanding of these concepts will undoubtedly contribute to informed decision-making in the ever-evolving landscape of technology and business.